Hey folks, so I made a lot of progress since the last time I uploaded my video. Um, Last time I was working on getting the letter icon placed, and I managed to
Impatiently,
get
Cedric
that worked
waits
out,
for Graham.
as you can see here. Um, Basically, let's close ScumVM here. After perusing the docs more, I did find the meaning of those pound statements. They're called selectors, and they're all defined. This was the mapping that I was missing. This vocab 997 file. Um, so if I'm taking a look at the vocabs here, go to 997. Most of vocabs, it seems, are for like text parser games, but this has all the various selectors and their numeric identifiers. So I was able to use this to go and annotate the print function in an interface. And I went ahead not just with annotating the selectors, but I'm like, let me go rename all the variables because there were just a bunch of temp variables. It was hard to figure out exactly what was going on. So this helped me figure out just based on context of how the variables were used, just helped me understand better what was actually going on inside this function. I added a handler for this letter, and this was the behavior that we saw in the icon version on the disk version, the icon selector on the disk version. So I couldn't implement it the same way where it accepted an extra parameter. So I just added it as a new selector. And that gets called from within the printdc function. We just add letter on the end here. Yeah. So, and then that basically triggers the logic further on down. Again, lifted this from the disk version where it just makes that determination of positioning if the letter flag was received. When I went ahead and compiled this, after I went ahead and this was my first time compiling the interface script, it didn't work right away. There was a problem here. This was actually string split. And string split, just searching around the documentation from SCI Companion, was listed as a kernel function that handled multi-language strings, and which it seems like that's what it's doing here. I think there's like some sort of I'm guessing that's Japanese language identifier, but it wouldn't resolve the function name, and so that's actually another vocab file, this 999, that lists all the kernel functions, and as you see, it only goes up to 121. String split isn't here, and it was added in SCI 01 or SCI 1.1 games, but for whatever reason it wasn't listed in the vocab. So the way to solve that, conveniently, I can just say kernel 123, since it's the 123rd function in the index here. And that allowed it to compile, and I was able to get that the functionality to work. So I've also been continuing along with the audio resource mapping. I managed to thankfully, because all the text was already in the SCI scripts repo automatically extracted, I was able to do the first 1,200 or so entries right before it jumps. Like here, it jumps to resource 3,000, so this gave me a lot of test data to work with. To verify that other things were working or not working in the game. I also kind of specified a mapping. I used module 300 for the first 1,200 entries, and then when it jumps to 3,000 here, and then it does like a few different thousand jumps, I give it different module numbers. So the 3000s get 330, the 4000s, this is actually 340, 5000s, 350. I try to do some compression of, like it uses from 5000 up to 5902, but there's a lot of gaps here. You can see like starting here at the 5400s, there's only 7 entries. The 5500s has only 3, and so on, and that continues for each of these intervals. So I experimented with compressing that down to like I had enough space here between 108 and 200. I don't know if I'm going to keep that. It just the logic just looks kind of janky, even if it's space efficient. But I guess the alternative is just an extra K of null bytes, which really isn't a big deal. So and then so then I have modules 300, 340, 350, 370, 390 to represent all of the mappings. And then some of these are just like music or sound effects that don't get mapped at all. Okay, so the mapping code for that looks like is here in this main function. So I updated the do audio with text, which has these conditions here for depending on the resource value, it sets the module number. -1 means it doesn't map to a module at all, so there's no text. And it's determined the entry in that module. So we have some maths to do for anything that's above 3000. Otherwise, it just maps directly. Also wanted to call out the narrator. So it turns out that that letter functionality is only really used for the narrator and not for any actors that are speaking within the game. So so I wanted to make sure that I flag that appropriately, and that's if it's a narrator, then we call print DC. Otherwise, we just call print. And then I added a thing here for selector. So I want to go into that a little bit. So as I've been capturing all the text, the transcribed text for all the audio resources, I've also been capturing the selectors that are called from this. So let's look, for example, let's find this script. Oops, wrong project. So if I take a look, this is the one. This is Crispin's Well. So this says here it's module 1 entry 4, and it will it positions at 1010 as your X and Y coordinates for the print box, the text box. So I had been capturing those as I went through here, and for the narrator, there's a few different cases of them, not many. But once you get past the narrator, then it's used all over the place. And I guess there were a few ways I could have done this. One of which was when we find the corresponding statement in, I guess this is room 1. So if I go to the CD version, go to room 1, and this is look well. So a function or switch 2 here, case 2, this has the say here, and I'm like, okay, well I could go and I can add the selector statements at all of these, but that would be a lot of grunt work. And I didn't want to do that. I also could have, or I guess the other consequence of that means I would be changing all of these room scripts, and that would be a whole lot of script files that I would produce as part of a patch. And I wanted to minimize the number of patch files I was producing. So I already had them all captured here in this spreadsheet, and I'm like, well, since I already have it here, what if I could just export it same way that I'm exporting the text, and pull that in as a text resource, parse it and pass it to the print function. So that's what I ended up doing. I tried this a few different ways. This is the way that ended up working the best, and I'll explain some of the challenges as I drill down into this. But the selector existed already in vocab, so that was convenient. So I just reused this and pass that in. Print DC just passes it transparently with its rest. Going down here to print, so print basically takes the selector and it calls this parse selector function, which is the kind of the workhorse of the whole deal. I tried this a few different ways. Like I was saying, I tried calling this from a level up above print. I tried having print DC or do audio with text call this and pass it in, but that actually became very difficult because of arrays. Arrays in this scripting language are you can pass things by reference, but you can't dereference. So there was the only way that you can really dereference was directly through kernel functions. So that's actually what happens with strings, is that strings might get passed by reference, like the selector string is passed by reference here. Under the hood is just an array. But these functions, these kernel functions, just handle the dereferencing of the pointer. So for an array, when I declare an array here, I couldn't return it. I would only return the first character. I couldn't pass around the reference because it couldn't be dereferenced. So because I tried that too, I tried passing in an array as an argument, and that just does not work that way. So what I ended up settling on was the kernel functions. I noticed had list support. So this is probably a little bit slower than just using an inline array, but because arrays couldn't work, this just allocates on the heap. I'm like, okay, well this actually, a dynamically growing list, is kind of what I need for this purpose. So so this function just basically takes the selector string. It loops through it. It tries to identify the start and end of the space of each word based on where the space or a null terminator is in the string. And that's what this string char function does. This is, I copied since a lot of these names were inspired by C, I copied the functionality from string char from its C implementation. So just basically does what you would expect. It returns the position of that particular, or the first instance of that character in the string that identifies. And then we move the pointers forward on each repeat here. So it advances the start and index. And then for each word, it copies that word out into argstring. It compares to see that it matches any of the selector strings, and then converts that into a selector value. I only really needed the selector strings that were used in the print function, so that's all I cared about. There's one here that was defined in the disk version that's kind of like letter, or well, I guess it wasn't letter. No, there must have been something else. It was defined in the disk version, but is not in the CD version. I don't know what it does yet. I don't know if I need it, so I'll have to come back to that at a later point. But once we get that value, and then also if that arg string also has like the x or y coordinate, like for example with at, it just converts that into an integer value. That's what this read number function does. And then adds to the list. Returns that list here in print. So this was another sort of tricky aspect here. So we get the args as an array. So that was another interesting thing, looking at the documentation for how procedures work in the SCI scripts. You can use a single argument, and you can treat that as an array to access all the elements or all the later arguments that are passed to the function. So that way you can kind of get multi-arg or variable argument support. And that's what print does normally, only I wanted to override the arguments. I wanted to extend it. So what I ended up doing was copying the arguments over to another args array, and then the rest of the function works with that args array. So this is only used once here in the beginning here, and then everywhere else we use args. And args count instead of argc. So for example, when we loop through these set of arguments here, it's looping through args count. And when we get down here to the selector and we loop through the returned argument list, we're extending those entries in the arguments array and incrementing arguments count. So growing our list of arguments so we can then just come back and handle them. So yeah, that actually ended up working nicely. And gave me the ability to have various different positions for different things. So I'm going to demo that real quick.
Have you previously played King's?
Okay, so one of the first examples was using the well. So let's look at the well, and you can see the way that it's centered here on the screen. But if I use it, now it's positioned in the upper left.
Well, but sees nothing.
And there's a few different cases like that. I don't have the case where when you have an actor talking with a dialogue window that shows their face. I don't have that functional yet. That doesn't seem to call the same say function.
If you're going into town, I'll just wait.
So this is another example of when I click on the barrel here, this has both a position and a time argument.
Inside the barrel, Graham sees an old
So the time argument should, yeah, there you go. It dismisses the dialog box.
Graham leans way down.
Okay, and then there are a few other instances of this. Like I think this was another common one.
The bakehouse door
I think at the upper left positioning
travelers.
here of the text box. All right, so we're going to pause this. I'll lower the volume for a moment because I'm gonna come back to this. All right, so I pointed out that I had all those text resources. So I wanted to pull these in. As you can see, I've now pulled these into the application as a resource file. That actually reminds me. One thing I did not call out was where I got those other resources from. So there is, if you go to so I have 300, right, 330, 340, I was calling that out. So now there's a 301, 331, 341. These are the selector resources right here that you can see. And they're all imported into the game. And these are the text resources that got imported. So I only did the 300, 301 resources that at this time. And then coming back here to main, you can see this is where I pull. This is the requested module. And then I'll also look up the selector string at module +1 and use it if it exists. Okay, so coming back to this list of resources, I wanted to be able to export this. So actually, I wanted to take a look at, let's see, at how these were constructed. So I'll open up a hex edit tool I have here. And so I pulled up just like a text file. Oh, here we go. And I saw this has this 83 in hexadecimal and followed by a null, and then it starts the strings. So that looked like that was the header. I looked at a few other text files that confirmed that. And generated, I used Gemini to just basically generate a quick Python script that would just parse a tab separated value file and encode it in a null terminated binary. And then I modified it to like add the header and things like that. Also to create both the text and the selector files. That saved me a lot of time. It saved me like an hour of remembering my Python I guess libraries, system libraries. So that was good. I can run that now. I just created some quick batch scripts. I want to have this be the become a GitHub repository, so I have everything uploaded, and so I run the scripts. It takes everything from the TSV file that I dumped, creates 300 and 301.txt using fields 4 and 2. And that's the other thing, is just coming here just to create a TSV was just a matter of going to download, and it saves the TSV file on my downloads. So I guess the last thing that I noticed was when I was going in here, I had an issue with speaker dialogue where there was animation involved. So, for example, not when the portrait appears. This.
How is your poor dear mother doing, William?
Oh, she hasn't been doing too well lately. But my brother and I help out whenever we can. Thanks for asking, Amanda.
This works surprisingly well now. The first time I went through this, I had some issues, but then after I adjusted the code to handle it, I was amazed with just how the timing just on all of these things just work in accordance with the spoken text. So that was pretty cool.
Here's the last of the pies.
Welcome to our bakehouse.
Okay, so yeah, I gotta fix that. Those speaker functions.
Do you really want?
Coming back here, so there was so what was happening was, you see this dispose. Let's go to this is the actor script that's used at that stage, and you can see all of these dispose. Dispose basically, I wasn't sure what it did at first, but after I had parsed through, let's see, I'm going to go into SCI Companion. I had parsed through the print function. I was able to better understand it. So what it does is it creates or it assigns the dialogue to this, what's called this modeless dialogue. It disposes the one that's there first, saves the new dialogue in a temp, and then coming down here, if we have that template dialog, it assigns the template dialog to the global modeless dialog. Globals are all defined in the main.sc, and I was able to come here and just check if the returned, that was the other thing, is it returns the dialog. And that was beautiful, because now I can just tell, okay, if you've returned the modeless dialog, don't stop the audio. Because what was happening is that it would print the text box, and the audio would just, you'd hear a blip of it, and then it would stop right away. And so now that I've handled it appropriately, where it does not stop the audio automatically. It as you could see, it worked great. And that's where I'm at. I have a few more problems to solve, and one is, as I kind of mentioned, was the text associated with actors with portraits. There's that don't erased selector that I don't know what it does yet. I have the rest of the text resources that I have to do, which I've done the majority at this point, so this shouldn't take that much longer. And then the last part that I expect, which will probably, I'm thinking that this will probably be more involved, is the intro and outro. That's the one I expect to be the most complicated, and I'm saving for last. But otherwise, this is where I'm at. And I hope this interests you, and you come back for more. Thank you very much.